Okay. So good evening, everyone. And after a long break, we are back. I don't know how many of you remember what we were doing. I certainly don't. Do you remember what we were discussing in the last class? What was happening in the last class? Yes, sir. Karthik says yes. Yes, Karthik, tell me then. What we were discussing in the last class. Tell me.
Real depth and apparent depth.
Okay, we were dealing with real depth and apparent depth. So basically, we were dealing with, I think, let us just have a quick recap before we proceed any further. We were dealing with optical paths. We had seen that if light travels in vacuum and it travels in some other medium, the distance that it travels in the medium is known as the geometrical path, but that same distance, the same time, it would have traveled a different distance in air, and that is known as the optical path. Yes or no? We had seen that. Then we had seen refraction at plane surfaces. We had seen what happens if you have a body in the denser medium and you are trying to watch it from the rarer medium. This is the denser medium and this is the rarer medium. What happens if you are watching the body like this? It will always appear raised up. Yes or no?
Yes, sir.
And we had seen the formula which we can apply, whether it is going from denser to rarer or it is coming from rarer to denser. And the formula was like this: d real divided by d apparent is mu1, the first medium, divided by mu2, the second medium. Yes or no? Do we remember this?
Yes, sir.
And then we had seen that whatever distance it has shifted, that is known as shift or x, and that shift is real depth minus the apparent depth. And we have this formula for shift where mu r is the refractive index of the first medium with respect to the second medium. Will we recollect this? Yes or no? Do we recollect this?
Yes, sir.
Well done, sir. We recollect a lot of things, sir. We had seen some problems and we had seen a problem of JEE as well. And I told you that when light passes through parallel slabs, if the first medium and the last medium are same, it will always emerge parallel. For first ray is known as incident ray, the last ray is known as emergent ray. Do we remember this?
Yes, sir.
Okay. Then I think we were dealing with a problem, and that is where we ended our class in that day. And that problem was like this: a 20 centimeter thick glass slab of refractive index 1.5 is kept in front of a plane mirror. The object is kept in air at a distance of 40 centimeters from the mirror. Find the position of the image with respect to an observer near the object. What is the effect of separation between the glass slab and the mirror? Do we remember this question, bacha? We
No, sir.
had we have a glass slab and a mirror, and the glass slab is put in front of the mirror, and then they're asking you, we have kept, and these type of questions, they do come in JEE very often. I've seen this question, same question taken from a JEE advanced paper. How do we solve this question? How do I solve this question? I have a mirror, I have a glass slab, and I have an object. Yes, my dear friends. And you will have to remember what we have done. We had seen that if you put a glass slab on one side, we have an object. Then we have a glass slab. Then we are observing it from the other side. The object shifts. Yes or no? Do we remember this? So you have to use that, and then you'll have to tell me how are we going to solve this. Can you do this, or you want me to do this for you? Since this is a question after a long time. Everyone in the online class, Karthik, Deepak, Jayashankar, Shreya, Sainath, do we understand the question? You can draw a simple diagram. Remember, the diagram may not be very complicated. A simple diagram will serve a purpose. This is a plane mirror. Drawing the diagram correctly will help you. Then I have, let us say, I have an object O. The distance of the object O from the mirror is given as 40 centimeters. But I have a glass slab put in front of the mirror, obviously between the object and the mirror. The width of this glass slab is 20 centimeters, and the refractive index of this glass slab is 3/2 or 1.5. The first question is the green question. What is the effect of separation between the glass slab and the mirror? So if I call this distance as the separation, how does it affect your answer? Does it affect your answer? Because this is not given to you. How far is the slab from the mirror? Does it affect your answer? Yes. Karthik, Deepak, Jayashankar, Shreya, and everyone in the online class. Does this pink thing, the distance between the glass slab and the mirror, does it affect your answer? Yes or no? It depends. Thumbs up. It does not depend. Thumb down. Yes. Does it depend? Yes or no?
No,
It
sir.
depends. Yes, beta, what are you saying? Does it depend or no? Because that distance is not given to you. So if it depends, you will not be able to solve the answer, right? You will not be able to solve the question. Does it depend or does it not depend?
No, sir.
It does not depend. So it does not depend where you put this glass slab. Your answer does not depend on that. Now, can you solve the question and get the answer? How are you going to solve the question? If this glass slab was not there, the answer was pretty simple. Where will you get the image? The object is 40 centimeters ahead of the mirror. The answer will be 40 centimeters behind the mirror. Yes or no?
Yes, sir.
If the glass slab is not there, the answer is straight away forward, straight away behind the mirror, 40 centimeters behind the mirror. But what happens because of this glass slab?
Shift the mirror, sir.
The distance 40 centimeter changes. Yes or no? The object does not appear at 40 centimeters. Yes or no?
Yes, sir.
Will the object appear closer or will the object appear farther?
Closer.
Closer. So let us say the object appears here. Let me call this as O dash. Can you find out, can you tell me how much is this distance which the object will appear shorter if I call this distance as x? Can you tell me how can I find the value of this x? I hope everyone can see my screen. Can you tell me how are we going to find the value of this x? Do we remember this or shall I tell you how to find it out? This is what I am referring to. I hope you can remember this normal shift. How many of you remember this? Please raise your hands. Well done. So you have to put this formula. X is T, the thickness of the slab, to 1 minus 1 by mu.
Sir,
So now, bacha,
answer is 40 by 3.
answer is
40 by 3.
Answer is
40.
20 by 3.
40 by 3.
Okay. We have got at least 3 is matching. Great. Let's take baby steps since this is the first class after a long time, and we probably have been rusted for a while. First of all, tell me the value of x. How do I get the value of x, bacha? This will be equal to the thickness T into 1 minus 1 by mu. Yes or no, my dear friends? We understand this?
Yes, sir.
T, how much is this T?
20.
T is 20. Well done. How much is this mu?
3 by 2.
Mu is 3 by 2 or 1.5. I can put this value and get the value of x, and the value of x would be 20 by 3. Yes or no, my dear friends?
Yes, sir.
So that is the first answer that I have got. The value of x is 20 by 3. So this x is 20 by 3. So now what is the effective distance of the object from the mirror, my dear friends? This is the effective distance. Can you tell me how much is this? This is the value of u, the distance of the object. U.
100 by 3.
So this u will be 40 minus 20 by 3, and that I think is 100 by 3. Yes or no?
Yes, sir.
That is 100 by 3. So now if the value of u is 100 by 3, you know now how much will be v. Where is the... Wow, Karthik, 80 by 3, that is correct. Well done, Karthik. Well done. 100 by 3, my dear friends. 100 by 3 is the distance of u. The object now appears 100 by 3 from the mirror. Where is the image form? Image will form on the other side. Yes or no? No, yes. Let us be fast. This is the image I1 dash that is formed. And the value of this v would be how much, my dear friends? 100 by 3, yes or no?
Yes, sir.
Yes, sir.
Okay, now this would have been the answer if I would have been watching this from somewhere else. But the object is near. The observer is near the object. That means I'm here. This is my observer, my dear friend. This is my observer. He looks like an alien, but he's an observer. Now, when he sees this, he will not see it 100 by 3 from the mirror because he is also seeing it through the glass slab. Do we understand this, my dear friends?
Yes, sir.
He is also seeing it through the glass slab. Therefore, this will again shift. Yes or no? No, yes. This will again shift. How much will it shift? How much will it shift? The actual object which he has to see was here. But it will shift. How much will it shift? It will shift the same distance because it does not depend on the distance. It only depends on t and mu. Yes or no?
Sir.
So it will shift in this direction. Yes or no? It will appear closer. Yes or no?
Yes, sir.
How much distance it will shift, my dear friends? Same
20
distance.
by 3.
20 by 3. Yes or no? So it will appear I double dash here. And how much is this distance, my dear friends? The total
80
distance
by
is 100
3.
by 3. I take out 20 by 3 from it.
Answer is
So it
80 by
will
3.
be 80 by 3. Do we understand this? So it will appear at a distance of 80 by 3 behind the mirror. And since we are watching it through the slab, there is some bit of refraction, reflection. The intensity of the image will be less compared to the brightness of the image. The intensity of the image would be less. Do we understand how this is done? Can I have raised hands from everyone in the class that we have understood this? Girls, do you understand the difference?
Sir.
Yes, beta.
Yes, sir.
Okay, note it down. Copy it. Okay, beta. Let us wait for the other students to copy it so that we are all on the same page.
Done, sir.
Done, sir. Well done, sir. Then we can probably move on ahead in life, sir. Yes, sir. Shall I?
Yes, sir.
Okay. Well, then, let me give you one more question. And I sincerely hope that you are able to solve this. And I would be very happy if you are able to solve this. This comes as, oops, why it is not coming? Let me try it again. Okay. The only difference between this question and the previous question is the type of mirror that I have changed. Oops. Okay. An object is placed 21 centimeters in front of a concave mirror, plane mirror, concave mirror, of radius of curvature 20 centimeters. A glass slab of thickness 3 centimeters and refractive index 1.5 is placed close to the mirror in the space between the object and the mirror. The position of the final image formed if the distance of the nearer surface of the slab from the mirror is 10 centimeters. Can you do this for me? I'll wait for a minute and I hope that you can solve this for me. Anyone is confident? Same question. Same question.
Sir, 20, sir.
Yes, bacha?
20, sir.
20 from the mirror. Okay.
Sir.
Thoda sa difference. Small difference. And why is that small difference coming?
21, sir.
In the first question that I told you, there was no. Okay. Let us wait for the other things, other answers. 20 centimeters, just a bit of thing that you have neglected probably.
Minus 21 centimeters.
Minus 21 from the mirror. That is correct. Not minus 20, but minus 21. Well done. How many of you got this answer? Please raise your hands. Only one? What about the others? Two. Backbenchers, 3, 4. Karthik also got the answer. Well done. Well done. So how am I supposed to do this? First of all, we have to understand that because of the slab, it will shift. Yes or no? So this object which was here will appear somewhere here in the direction of light. It will shift by some distance x.
1 centimeter.
And this x is very simple, t into 1 minus 1 by mu, and I think everything is given. So what is the value of this x coming as, my dear bacha? 1 centimeter, yes or no? This x is coming as 1 centimeter. So your actual u, which was minus 21, now becomes
20.
minus 20. Yes or no? Do we all understand this? Yes or no?
Yes, sir.
Now I can put the mirror formula 1 by v plus 1 by
Minus
u
20, sir.
is equal to 1 by f, and I know the values of everything. I know the value of u is not 20 but minus 20. Yes or no?
Sir.
I know the value of f because I know the radius of
Minus 10
curvature. Radius
centimeter.
of curvature is 20. My radius of curvature is minus 20, concave mirror. So the focal length is minus 10. I put the values. I get the value of v. What is the value of v I'm getting, my dear friends? It will be minus 20. Yes or no?
Minus 20 centimeter.
So minus 20. But again, this minus 20 means it is on the other side of the slab. So therefore,
Yes.
again, it will shift. Yes or no?
Yes, sir.
Shift in the incident light. Incident light is now the reflected light. So it will shift away. Yes or no?
Yes, sir.
1 centimeter away. So the final image is formed at, oops, what has happened? It has gone in the air. The final image is formed at minus 21 centimeters from the mirror. Do we understand this, my dear friends? Please raise your hand so that I understand that we get this.
Yes, sir.
Everyone understood this?
Yes, sir.
Well done. Good. That means this vacation has not. I was worried that since you have gone on to vacations, you might have lost the touch. But I'm very glad to see that we remember things because these are not simple questions that we are discussing. These are somewhat typical questions that we are discussing. Shall I move ahead in life now? Everyone has noted this down? Or do you want time to note it down?
Noted, sir.
Everyone, online class, offline class, girls, your camera, I think, is not working and I can't see you. So can you just speak and let me know that you are done? Huh? Online bachas? Karthik, Deepak, Jai Shankar, Shreya, are we there? Have you noted it down? No, yes, yes, no. Copied. Think everyone has copied it then.
Noted, sir.
Okay. Copied. Chalo, then we bring the next heading in front, and that is known as this one, total internal reflection. What? Surprising heading probably, because the topic that we are doing is refraction. Now in refraction, how does reflection come? Total internal reflection. Does anyone know about this total internal reflection? Can anyone tell me what is this total internal reflection? 1 minute. Can anyone tell me what is the total internal reflection? Anyone has heard about this term? This is a yes, this is a no. Yes? No. Yes?
sir.
Yes, beta?
We heard, sir.
Not heard?
We heard this term.
Sorry, I can't hear you, bacha.
We know this term, sir.
You know this term. So can you tell me what do you know about this?
Light, instead of refracting, it reflects.
Light goes from reflection of light within the medium. When does that happen, Karthik? When light goes from
Denser medium to rarer medium.
well done. When light goes from denser medium to a rarer medium, it will bend away from the normal. Yes or no? When light goes from denser medium to rarer medium. Do we remember this DRA? I told you the short form DRA, DRA, DRA.
Yes,
We remember
sir.
this? When light goes from denser medium to rarer medium, it bends away from the normal. It bends away from the normal. Oops, what has happened here? Something wrong. When light goes from denser medium to rarer medium, I just wanted to put the thing here. Okay, it bends away from the normal. Yes or no? This is just a diagram. It is going from denser medium to rarer medium. It goes away from the normal. We know
Incident
that.
rays maximum.
We know that sin I by sin R is mu 2 by mu 1. Yes or no? Or mu into sin I is a constant. Snell's law. Yes or no? Yes or no?
Yes, sir.
Now, if I keep on increasing the angle of incidence, more, what happens to the angle of refraction? Does it increase or does it decrease? If I increase the angle of incidence, what happens to the angle of refraction? Does it increase or does it decrease?
Increase.
It will increase. Angle of refraction will keep on increasing. I'm increasing the angle of incidence. The angle of refraction is increasing. So there will come a stage. What stage? Stage number 2. There will come a stage where what? At some angle of incidence, which we call as critical angle, the angle of refraction becomes 90 degrees. Do we understand this?
Sir.
At one particular angle of incidence, the angle of refraction becomes 90 degrees. That
Sir.
angle of incidence is known as critical angle. Yes, bacha?
If incident ray is maximum, ray reflects back into the same direction.
Give me time to show my talent. Please. Do we understand up till here? I am increasing the angle of incidence. The angle of refraction is increasing. At one particular angle of incidence, the angle of refraction becomes 90 degrees. Note it down. That angle of incidence is known as? That angle of incidence is known as?
Critical angle.
Write it down. What is critical angle? Critical angle is the angle of incidence for which angle of refraction becomes 90 degrees. Do we understand this? Do
Yes,
we
sir.
understand this? We can find
Yes,
out the
sir.
value of this critical angle in terms of mu. For example, if I call the refractive index of this as mu, and this is air whose refractive index is 1. Yes or no? Do we understand this? I can say mu into sine C will be equal to 90 into sine of 90 into mu of air. Yes or no? No, yes?
Yes, sir.
Mu into sine I is constant. Remember Snell's law.
Yes,
So
sir.
from there, can you tell me the relation between mu and sine C? Quick. Apply Snell's law. Apply Snell's law. Tell me the relation between mu and sine C. Let me see who can tell me the relation first. Fastest finger first.
Mu sin I equals to 1.
Arey, tell me the relation straight away. I ask you a question, you ask me a question back. That is not an answer, na? Mu and sine C. I think you will get this relation. Mu is equal to 1 by sine C, na? You were saying mu into sine C is 1. I am saying mu is equal to 1 by sine C. You will say same thing, na? But this is how you remember it. If you want, you can remember it in this way. Mu into sine C is a constant. Do we understand this? Yes or no?
Yes, sir.
Raise hand will give me more confidence. Now, if I change this question, remember this critical angle depends on both the mediums. It depends on both the mediums. It depends on both the mediums. Will you remember this? Because this might be a question that comes in JEE. Critical angle depends on the two mediums. This critical angle depends on what? Depends
Two
on the
mediums.
medium. Will you remember this? Yes or no? No, yes. So for a pair of mediums, the critical angle is different. It depends on the two mediums. Depends on the two mediums. Now, let me do one more thing here. Now, let me give you another case where this is mu1, refractive index is mu1, and this is mu2. Remember, whatever we are doing are potential questions that are going to come in the examination hall. They are not theory. They are not theory. They are questions that are going to come in your JEE. Do we understand this? Do we understand this? Yes or no?
Yes, sir.
This is mu1 and this is mu2. Which one will be more? Mu1 will be more or mu2 will be more?
mu1, sir.
Ah? Mu1 will be more or mu2? Mu1 is denser. Mu2 is rarer. So mu1 will be more and mu2 will be less. That is correct. Now, can you tell me the relation between mu1, mu2 and C? This C would be the critical angle for these two mediums. And remember, for different mediums, the critical angle changes. And there's a very, very good question that came 2 years back in one of the JEE, that was JEE. When I say JEE, that means JEE Advanced. That was based on an optical fiber. I'll show you an optical fiber, and it was having total internal reflection. I did the same question with a student of mine. I told him, देख बेटा ये गलती करके आएगा तो examination hall में, because I knew कि क्या गलती करेगा वो. And he did the same mistake while he was solving the question. Same question appeared in, I think, JEE of 2020 or maybe 19, maybe 20, maybe 20. Just check out JEE Advanced, maybe 2019 and 20, that question came, optical fiber. Same question we did in the class. I told you to see, you are going to repeat this mistake. That question came, he came back to me and said, sir, I did not do the mistake. And I knew the answer and I just ticked it. He is right now in IIT Kanpur doing civil engineering. His brother is also, I'm also teaching him sometimes. Anyways, what is the answer for this one? I just lost, I got lost in the story. Yes, what is the relation between mu1, mu2 and C? Yes. Huh? Tell me. For this particular case, tell me what is the relation? This one was, this mu
mu1
was.
equals to mu2 by sin c.
Okay, that is correct. So you can write this in this fashion: mu1 by mu2, rarer by denser by rarer, is equal to 1 by sin c. Do we understand this, everyone?
Yes, sir.
Okay, so now let us recollect what we have done. When a ray of light is moving from denser medium to rarer medium, it will always bend away from the normal. If I keep on changing, if I keep on increasing, yes, Manasa, any doubt, beta? If I keep on increasing the angle of incidence, the angle of refraction also increases. For one particular angle of incidence, the angle of refraction becomes 90 degrees. That angle is known as critical angle. For mu and air, the critical angle mu is equal to 1 by sin c. For 1 and 2, mu1 by mu2 is equal to 1 by sin c. Do we understand this? Yes or no? No, yes. Huh?
Yes, sir.
Sir.
Has everyone noted this?
Yes, sir.
Now, my dear friends, the question is, what happens if your angle of incidence, it's not happening here now, what happens if your angle of incidence is more than your critical angle? What will happen then? Tell me. It cannot go any further because 90 degrees is the maximum angle that can have. What will happen if the angle of incidence is more than critical angle?
It enters to the same medium.
Yes. If the angle of incidence is greater than your critical angle, it cannot go into the other medium. It bends back into the same medium. Then it is no longer reflection, no longer refraction. It
Total
becomes
internal
reflection.
reflection.
This reflection is known as TIR, total
Internal reflection.
reflection. And then we follow the laws of reflection. The angle of incidence becomes equal to the angle of reflection. Do we understand this? That is the phenomena of TIR. TIR is total internal reflection. It happens. What are the 2 points that you must remember about TIR? Point number 1, yes. Point number 1.
Incident ray must travel from denser to rarer.
Yes, the ray must pass from denser to rarer. It cannot happen the other way around.
And angle of incidence must be greater than critical angle.
Angle of incidence must be greater than critical angle. Everything just comes back in the same medium. This phenomena is known as TIR, total internal reflection, my dear friends. Is it clear to everyone in the class? Total internal reflection.
Sir.
Everyone understands this? I'll give you 1 minute to note it down. Total internal reflection. Have we noted it down, bacha, everyone?
Yes, sir.
Please raise your hand so that I know. Now, shall we move ahead? Or you want time to note it down?
Answer.
Okay, then important points about critical angle, and these are all questions. What all factor critical angle depends on? Critical angle. On what all factor it depends on? Yes, one thing you already know. Critical angle depends on. Yes, bacha, number one.
Depends on the medium.
It depends on the two mediums. Yes or no? For different mediums,
Yes,
it
sir.
would be different. Yes or no? What else?
Speed.
What else? It depends on the color or the wavelength of light, because refractive index depends on it. Do you understand this? Color or wavelength of light. We understand that mu for any body or for any medium is inversely proportional to 1 by lambda. Yes or no?
Yes, sir.
No. But we also know that mu is also now inversely proportional to 1 by sine c. Yes or no? Therefore, I can write lambda, or I can write sine c, or c, critical angle c, is directly proportional to lambda. If the wavelength is more, critical angle will be more. Do we understand this? Simple things. Simple things makes a lot of difference. Wavelength of red light is more than the wavelength of violet. Yes or no? Therefore, the critical angle for red light will be more than the critical angle for violet. Do we understand this, my dear friends? Yes or no? No, yes.
Yes, sir.
Anyone understands this?
Yes, sir.
What next? It depends on the temperature. And this is one thing that most of the students leave. When the temperature rises, my dear friends, the refractive index decreases, and therefore the critical angle increases. Will you remember this, my dear friends? All these are information-based questions. The only way to know them is by knowing them. There is no other way out. Do we understand this? Yes or no? No, yes.
Sir.
Everyone? You're on the same boat?
Yes, sir.
Okay, let me see if I can get you a question on critical angle. Where it is? It is here, I think. Okay, so here is the question. Everyone has noted this down?
Yes, sir.
Okay, then comes a question which is based on the application of critical angle. This is question number 1 for oops, why I'm using yellow color? Something wrong. Things sometimes turn upside down, and then we'll have to manage them. So, what has happened again? I don't understand. What is wrong? Okay. Here is the question, and the question is pretty damn simple. Find the maximum angle that can be made in glass medium. Refractive index is 1.5. If the light ray is refracted from glass to vacuum. I think this is from your sheet, from your module. Find the maximum angle that can be made in glass medium if the ray is refracted. So basically, which angle they are talking about? Which angle are they talking about? Just tell me, bacha.
Sin inverse of 2/3.
Tan inverse of 2/3. They're asking about the critical angle. Because if the angle is more than critical angle, and remember it is going from glass to vacuum, that means it is going from rarer to denser. The maximum angle that it can make, the maximum angle that it can make in the rarer medium is the critical angle. You just have to find out the critical angle, and you can just put the formula mu is equal to 1 by sine C. Yes or no? From here, mu is given as 3/2. 3/2 is 1 by sine C. So from there, I can get the value of sine C is 2/3. So critical angle is sine inverse 2/3, and that is the answer that we are looking at. Do we understand this, bacha? Yes or no? Everyone? Everyone got this answer?
Yes, sir.
Can I give you the next question?
Yes.
The more the questions that you do, the better you become, because then you can solve the questions without any trouble, because you are confident. Remember, the only way students, oh, where is my mother? Students always ask me, sir, how can we become confident in solving questions? The only way you are going to become confident in solving questions is by solving a lot of questions. That is the only way I know, and I can tell you that is the only way that is possible. So more the number of questions that you solve, the better are your chances that same question is going to come in the examination hall and you can do it. Are you ready for the next one? Here.
Yes, sir.
Find the angle of refraction in a medium whose m is mu basically, whose refractive index is 2. If the light is incident in vacuum, making an angle of twice the critical angle. Read the question properly, solve it. I'll give you a minute.
Plus 2.
Yes, bacha, do we have an answer?
2 into sine inverse 2.
Yes, beta?
2 into sine inverse 2. 60 degrees.
Angle of refraction, they are asking, my dear friends. You are telling me, okay. So basically, what is going to happen? Total internal reflection is going to happen. Yes or no? First of all, you can find out. Yes, everyone has solved this question? Yes? No? Yes? No? So how do we solve this? Solution. Let us find the value of sine C. Sine C is 1 by mu. Yes or no, my dear friends? So 1 by 2. Sine C is 1 by 2. So critical angle becomes 30 degrees. Yes or no? Can I raise hands from everyone in the class? That we understand this. My critical angle is 30 degrees, my dear friend, and it is given that the angle of incidence is twice of that critical angle, so my angle of incidence becomes 60 degrees. Yes or no? Everyone understands this?
Yes,
Now,
sir.
angle of incidence is greater than critical angle, so is refraction going to happen? Yes or no? Yes or no?
TIR.
No.
TIR will happen, my dear friends. So angle of incidence will become same as angle of reflection. The question was wrong. It was not reflection. So there is no refraction. The angle of reflection becomes 60 degree. Do we understand this? Can I have raised hand from everyone in the class? Can we understand this, sir? Huh? Only boys understand this? Girls? Something wrong? Well done. So there is no refraction. There is only reflection. And the angle of reflection is 60 degree. Yes or no? No, yes. Small problem though, my dear friend. Small problem, a very small problem we have missed. And what we have missed? For TIR to happen, it must go from a denser to rarer. Why I'm using that color? It must go from denser to rarer, my dear friend. And here, if we have read the question correctly, it is going from air to the medium, so from rarer to denser, and therefore TIR does not happen. Do we understand this? TIR does not happen. Do we understand this?
Happen.
Yes or no?
Sir.
No, yes.
Yes, sir.
Now we apply Snell's law, my dear friend. Mu into sine I is constant. Mu is 1 for air multiplied by sine of 60. 60 is the angle of incidence. That will be equal to 2 multiplied by sine of r. Do we understand this, my dear friends? Yes or no? No, yes. Sine 60 is root 3 by 2, my dear friends. So root 3 by 4 is your sine of r. So r is sine inverse, oops, root 3 by 4. Do we understand this, my dear friends? Yes or no? Do we understand why TIR is not happening?
Yes, sir.
Well, that was all about TIR and total internal reflection. In the next class, we shall move ahead and probably do, let's see what to do. I will think about it over the night. There are two options from here. I can either go and solve prisms, or I can go in the normal flow where I normally go with refraction at curved surfaces. I'll think about it and I'll come back and see how we are going to do. Most likely we are going to go with prisms, because I think we should be, since we are dealing with refraction at plane surfaces, we'll complete the plane surface and then we will move on to the curved surfaces. So that's it from my end. If you have any doubts, you can ask me. Otherwise, take care and may God bless all of you. Bye bye.
Bye.